Hello, friends of chemistry. I'm working with Martin. Say hi, Martin.
I did say.
Ah, okay. Should I start over? We're doing on your owns. 10.4 is where we're going to start. 10.4 can be found on page, so sorry, 332. Okay. So the first thing I want to say before we do it is that it's really important that in Module 9, you memorize the polyatomic ions, because from now on, you're going to have to do things like they're going to ask you in this problem. If you don't know your polyatomic ions, you're going to have some troubles with problems like these. So let's look at 10.4. It says, sorry, Martin, would you like to read it to us?
Not really.
Okay, I'll read it. Give the chemical equation that represents the reaction between each of the following. Okay, so what is the first one?
HClO3.
And the other one?
And KO3.
KOH.
Oh yeah, sorry.
KOH. Okay, so ClO3 is a polyatomic ion that you ought to recognize. If you look on page 288, if you don't have that memorized, you see it's chlorine, okay? And it has a negative charge, a single negative charge. How about the one on the right?
No.
Do you see a polyatomic ion in the one on the right?
No.
In potassium hydroxide, you don't? This, though, is a polyatomic ion. So these are our two polyatomic ions. This is hydroxide. You absolutely must be able to recognize. And this is chlorate. Okay? So which one of these two substances, Martin, is an ionic compound?
The one on the right.
That's correct, because it has potassium in it, right?
Yeah.
So what we're going to do is we're going to begin thank you, by remembering what we learned in the section previous to this. What did we learn, Martin? We learned that acid plus
Base equals salt and water.
or yields, really, yes, equals salt and water. What is water's chemical formula? I spelled it correctly. WATER. Thank you. What is water's chemical formula?
H2O.
H2O. Where does it going to come from?
Well, we got a couple.
It's going to come from him. This one, him.
Right.
This hydroxide. The hydroxide, which is the base, is the acid acceptor. The proton acceptor, the hydrogen acceptor, right? What's it going to accept the hydrogen from? This one, which is the acid.
Yeah.
So we're going to have acid, base. So now we have to figure out our salt. So let's take this and break it up, shall we? Where do we find potassium in the periodic table? Martin, can you please look here at the periodic table and tell me where we find potassium?
In the first column.
Correct. In first column, number 19. That means what?
It means that it has one valence electron.
So I'm going to write down K.
Negative.
No, I'm not going to do that. I'm
Plus.
going to write K plus. Thank you. How about this? One of those polyatomic ions. What is it?
Yeah, it's
OH negative. Come on. It's hydroxide. OH negative. Hydroxide. OH negative. You must know this because this is how you're going to often find your base. Really easy. Hydroxide, OH negative, right?
All right.
Almost all of your acid plus base yield salt and water are going to come, your water is going to come from here and here. That's what's happening, right?
Yeah.
All right. So how about this ion, this polyatomic ion? We know it as chlorate, right?
Yes.
H we know is going to be a positive. What's chlorate's charge? You should have this memorized.
Chlorate's charge is
But if you don't have it memorized, stop. You can't look. You can figure it out right here. This is a positive because it's hydrogen. So what's this?
negative.
Thank you. So it has to be negative. So we've got these things. So now we want to yield water. It's going to be this, right?
Yeah.
And what's our salt going to be?
It's gonna be KClO3
Yeah. How do we know which to put first? Stop. Don't write anything yet.
because it's this goes salt.
Now, how do we know which of these to put first?
Because positive comes
No, because this is a what kind of compound?
Non-polyatomic.
This is a what? No,
ionic.
it's ionic. And what? Stop. In an ionic compound, when you're writing an ionic compound, when we talked about nomenclature at the beginning of the year in the module 1, when you're writing an ionic compound, which comes first?
The ion.
Right, the metal. Which is the metal?
Yes.
So it's going to be potassium.
Chlorate.
Chlorate. Excellent. We don't need to know potassium chlorate in order to write it here. Do we need to do, Martin, anything with the balancing here?
Nope.
No, it works out because they're just all a single element. So it's going to be KClO3. All right. So our correct answer is going to be HClO3 aqueous plus KOH aqueous yields KClO3 plus H2O. And this is going to be obviously liquid, and this will be in the water. So how's that look?
Seems right.
All right. That's letter A. Now we move on to letter B. Let me know when you're ready for me to erase.
I'm ready.
Good. Okay, letter B. Can you read it?
Yeah. HBr and CaO2H.
What was it?
HBr and Ca open parentheses OH close parentheses 2.
Good. Okay, so again we have a case of acid plus base yields salt plus water. Okay, so here again we have the helpful marker of the hydroxide marking our base.
Yes.
So we've got the acid, we've got the base. Let's break up our ionic compound. Which one is that?
That's bromine.
Is bromine a metal?
Yes. Oh no, it ain't.
Right, it's not.
Carbon.
Calcium is a
That's
metal.
the one I
Okay,
meant.
so we're going to break this up, and we know this is a single negative, right?
Yeah.
So what does that tell us about the Ca?
It's positive.
2 plus, right? Because we need 2 of these to match one of these.
All right.
So when we make them, we reverse the signs and ignore the charges. Remember all that. So it's going to be, also you can look on the periodic table and find calcium. It's not that difficult to do. It's in column 2A, which makes it a 2 plus. So we've got that plus this. So let's say H plus Br negative plus Ca 2 plus OH. How many of these do we have?
2. Oh,
You two need to leave the room. You go to your room and you go to your room. Go now. Don't do that anymore. Hurry up.
I have to restart the video.
Go to your room. No, we're not restarting the video. We're in letter B.
Sorry.
Okay? So, where's our water coming from?
Look.
Look.
Well, okay, there's probably the hydrogen. Yeah.
So, where's our salts coming from?
The calcium and bromine.
Okay. So, we can see, looking at that they don't have the right numbers to balance. We need a balanced chemical equation.
Yes.
Not just any old chemical equation.
Yeah. Except no substitutes.
So important. That's right. Exactly, Smarty. So here we have this. Let's balance this. What's that going to be?
Okay.
We're going to reverse the numbers and ignore the signs. So we're going to say, I'll just write it here, Ca, because remember we want the metal first. Nope, we reverse the numbers.
Oh, CaBr2.
Yeah, we're going to need 2 of these for every one of these because that has to have 2 negatives to its 2 positives, right?
Uh-huh.
So that's what we're going to have. And how are we going to get 2 BRs? We're going to have 2 of them. So this is going to have to be 2, right?
Okay.
That will be useful because otherwise we won't have the right number of hydrogens for the water that we're forming, right?
Yeah.
We have 2 OH negatives. We need 2 hydrogens. That makes sense. So let's now write our equation now that we figured out what we're going to have in it. It's going to be 2HBr aqueous plus CaOH, close parentheses, 2. Okay. And now we have the right number on the right side that we're going to need. Also aqueous. Yields. CaBr2 and 2 H2O. And that's aqueous. Plus 2 H2O, which is liquid.
Okay. I got it.
Martin, why are these kinds of reactions called neutralization reactions?
Because the acid is neutralized by the base.
Yes, the acid and the base neutralize each other into water and a salt, right? Okay, let's look at letter C. Ready?
Yeah.
Yep, good.
I was.
Thanks. Good. Communication, it's the key. Okay, read it to me, please.
H3PO4 and Mg open parentheses OH close
Hold on,
parentheses
please.
2.
Mg,
Sorry.
open parentheses.
OH close parentheses 2.
Thank you. Okay. So again, we have acid plus base yields salt and water. Here's our base, bing. Here's our acid. So this is phosphate.
Yeah.
Right? And this is hydroxide.
3 minus, by the way.
Okay. What's that? Phosphate is 2 minus. 3 minus. Yeah. This is going to be, so we're going to have 3 H pluses, right?
Mm-hmm.
And we're going to have.
Magnesium is a metal, by the way.
Yes, this is our ionic compound here.
Uh-huh.
So we have Mg. What column is Mg in? It's going to be in the 2, right? Because it has to have a 2 plus in order to go with our hydroxide. And we have 2 OH negative, right?
Yeah.
This is what we're looking at. So these guys have to go together. And these guys have to go together.
Yes.
Mm-hmm. So how are we going to balance it?
Double the first one.
What if we have 2 of these and 3 of these? Is that what you were going to say? Yeah.
So then if we do
looks like it could work. Then we'd have 2 of these. And we'd have 6 of these. And we'd have 3 of these. And 6 of these. That would work. 6. Oh, yeah. Okay, we're in business, Buster.
Okay.
Okay, so we're going to say 2. So we figured out pretty much everything, but we still haven't written it out in its correct formula. So 2H3PO4, it's hydrogen phosphate, aqueous, plus 3Mg, open parentheses, OH, open parentheses 2, plus 3 magnesium hydroxide, also aqueous, will yield we got 6 waters, and we've got Mg 3, open parentheses, PO4, close parentheses, 2. How's that look?
Yeah, that's good.
Okay? Does it make sense?
Yeah.
And this would be aqueous. And this would be. Okay, so 2H3PO4 aqueous plus 3MgOH2 aqueous yields Mg3PO4 2 plus 6H2O. All right, good work, Martin. Low 5, slow 5. Ask us if you have any questions.